Welcome back to Math's Playground. Like I promised last time, we're going to do the second part of the story of a circle, areas and funky areas. So, um, we're going to have a few questions and maybe a riddle if I can think of one. Okay, so I did think of a riddle. Um, Here it is. What walks on four legs in the morning, two legs in the afternoon, three legs in the evening, and no legs in the night? Good luck, it's a pretty tricky one. Okay, so our first question, find a formula for the area of a circle. Alright, so we have a nice little circle over here. We're going to split this into a few parts. Okay, so remember, we're not using any like big formulas to find the formula of a circle. This is how the ancient Greeks did it. Well, our ancestors. So, um, we have 8 little parts, each of which are called sectors. And the curved part, I'm gonna square one of them. These parts, one of these parts is called an arc. So back to the sectors. So let's arrange them to look something like that, and then that's 2, 3, 4, 5, 6, 7, and 8. But this won't really help us find the area. So let's rearrange this part to look like um a shape that we know how to find the area of. So as we did in our last video, don't forget that the circumference is equal to 2 by r. Okay, um so here's half of one of these sectors. That's 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, and we have our eighth one. Okay, so the height of this as so-called rectangle will be the radius, which is r, and then each of these sides, the so-called length, will be half of 2 pi r, because notice how these parts are obviously part of the circumference, well, half of the circumference, because we have the same amount of the circumference down over here. So this is going to be pi r. So the area will be pi r square. So that's how, well, ancient Greeks found the area. Next question. Alright, so points A and B are on the circumference of circle with center O, such that angle AOB is equal to 120 degrees and OA is equal to 12. Okay, so we're going to try and draw a little diagram for this because questions don't always give us diagrams. So here we have a little circle. There's our point A and our point B. And here's our little center O. So it's just that we know that AOB is 120 degrees. So notice how it's going to be so easy if we draw a little sector over here, because that's what the second part is. We know that this is 120 degrees, and hopefully all of you know that the degree ratio of a circle is 360 degrees. So, and we know that OA is 12. So notice how OA is the radius. So we're going to use our little formula to find the area of the circle. So it would be pi r squared. In this case, r is 12, so pi 12 squared, which is equal to 144 pi. Okay, so now to find the area of the sector of AOB. So 120 is 1/3 of 360, which gives us that the area of sector AOB must be 1/3 of the area of the full circle, which we know is 144 pi. So we're going to divide 144 pi divided by 3, which gives us 48 pi. There we go. Alright, last question. I have a barn that is a regular hexagon as shown. Each side of the barn is 100 feet long. I tether my burrow to point A with a 150-foot rope. In this problem, we will find the area of the region in which my burrow can graze. Alright, so imagine you are the burrow, sketch out the area in which you can graze. Pay close attention to what happens when you try to go past point B towards point C. So, we're going to draw like how far this rope can go. So if AB is 100 feet long, then this can go only 50 feet extra. So I'm going to draw the length of the rope if the burrow pulls it taut. So here we go. So that's about how far the burrow can go. Same thing happens with AF. It can only go this far. Agreed? And then we're going to make we're going to make part of a circle. I'm going to make this part of a circle. Sorry, I don't have much space, so I'll have to make some of it here. There, that looks better. So we have part of a circle, and then the little part over here, which the burrow can walk up to. So, this part drawn in blue is the part in which the burrow can graze. So now we have to find the area, right? So for that, we're going to make some points. We're going to call this H, I, and J, G. So now let's find out the angles of the hexagon. So this is a regular hexagon, as it says right here, which means all of the angles are same. So we have a little formula to find the angle of any shape. So this is for the full shape, not just one angle. So here goes. it's 180 times n, when n is the number of sides, minus 2. So in this case, this would be 180 times 6 minus 2, which will give us 720. So one angle would be 120 degrees. Okay, so that helps. So we know that angle A is 120 degrees, which gives us that this little part is 214 degrees. So we know that that arc HG is 2/3 of a circle with radius 150 feet. So let's find HFI and JBG first. We're gonna start off easy and go on to the next part. So we have 120, right? Which means this part must be 60 degrees, which gives us that this is 1/6 of a full circle. So this would be 1/6 pi times 50 squared, because over here, HF, which is the radius of the little circle, is 50 feet, which is equal to 1250 divided by 3 square. Oh my god, feet. This here is tiny. Alright, so now let's find the area of arc HG, well, major sector HG. So that would be 2/3 times something, because we know that it's 2/3 of a circle. So 2/3 pi times 150 squared, which is equal to 115,000 pi. So now let's add up. We have, I'm gonna use this little space here, 15,000 pi plus 2 times 1250 pi divided by 3, because as you can see, we only found the area of HFI, and JBG has the same area. Oh my god, I always get mixed up with J and G. So similar. So that gives us 47505 divided by 3. And if you want the unit, it would be square feet. So here's our answer. And we finished the question, which means I've got to tell you the answer to my riddle. I'm going to say it again just in case you forgot. What walks on 4 legs in the morning, 2 legs in the afternoon, 3 legs in the evening, and no legs in the night. So here's the answer. A man, because a man walks on four legs in the morning. Well, when he's a baby, he walks on four legs, which means crawls on four legs. And in the afternoon, when he grows up to walk on two legs in the afternoon, in the in the riddle, then in the evening, when he's an old man walking with a cane, that's three legs, the cane, and people's two legs. And then no legs in the night means after you've died and you're a ghost, well, of course they're real, you move around with zero legs. This might be a popular one. I haven't heard it much. See you next time.